Hello, we are CLAWS, the Collaborative Lab for Advancing Work in Space from the University of Michigan. Our team is a multidisciplinary group of undergraduate and graduate students from across the University of Michigan developing software to further human space exploration. The CLAWS faculty advisor is Dr. Leah Sterling, an associate professor in the Industrial and Operations Engineering Department who specializes in human factors. To introduce myself, I'm Riley, the CLAWS team lead. I will be giving a brief overview of our project. From the suits RFP, there were two aspects of the problem statement that especially stood out to us: granting astronauts independence and equipping them with tools tailored to the lunar environment. In response, our team decided to focus on streamlining exploratory tasks by creating a flexible and non-intrusive toolkit. We call this system ATLAS, the AR Toolkit for Lunar Astronauts and Scientists. ATLAS interfaces with the External CLAWS Mission Control Center, or MCC, for communications and data transmission.
Hi, my name is Sahil and I'm the sysadmin for CLAWS. I'll be taking you through some of the infrastructure for Atlas. The building blocks of the Atlas infrastructure are protocols and modules. Each protocol is designed for a specific mission state and has modules which provide the core functionality for each task. In addition, utility classes contain general use functions to streamline development. The protocol manager runs at startup and ensures smooth transitions and continuity between protocols and their modules. Here we can see an example of the sample collection protocol broken down into the various modules and utility classes it leverages. For navigation, our goal is to provide guidance through waypoints while minimizing obstruction to the astronaut's field of view. In addition to the general use case waypoint, we have special classes for landmarks, sampling sites, and hazards. These waypoints are used as destinations the astronaut can be guided to. Additionally, astronauts can set waypoints at their current location during the EVA.
Hi, I'm Rupal, the administrative lead for CLAWS, and I'm going to be talking about the rest of the modules. For the sampling task, our goal is to support planetary science operations through GeoNodes. GeoNodes consist of sampling specific mission tasks, associated imagery, audio recordings of voice notes, QR codes of the sampling containers, and a waypoint that marks the sampling site. This information is stored on the MCC and can be accessed easily during post-mission analysis. To support all of these objectives, we put together mobile support equipment. This includes a suite of external sensors connected to a Raspberry Pi for data storage and processing. To address the drastic changing in lighting in a lunar environment, we have included an external lighting source that is activated by photoresistors. The primary way to interact with Atlas is through voice commands. Our voice assistant, Vega, leverages conversational AI to create a seamless experience. The user could ask Vega about their heart rate, whether there are any warnings, and how long the water supply will last.
Hi, my name's Caesar, and I'm the Mission Control Center lead. I'll be taking you through our MCC, where it serves as a central hub that will be used by everyone on the team in every stage of the mission. Here, the team can review the plan beforehand, view live data and make updates during the EVA, and finally analyze the collected data after the mission is over. The control room page displays an overview of everything that's happening in real time, including biometrics, communications, and GeoNodes. This is a view of our navigation tool. We're currently using the Bing Maps API to display all of our waypoints, which are listed on the left. Here's our GeoNotes tool. The notes are listed on the left side, and clicking on a note will pull up its details on the right panel. Aside from the mission-specific functionalities, the MCC also provides other miscellaneous tools, such as mock telemetry and warning streams. Our design philosophy for Atlas is centered around minimalism and uncluttered user interfaces. The display also needs to be readable in both bright and dark environments. Additionally, we wanted to standardize the design across different modules so that the overall system felt clean and intuitive.
Hi, my name is Emily, and I'm the software lead for CLAWS. I'll be going over a demonstration of what our front-end system looks like. First, the task list displays the ongoing mission and can expand to show previously completed and future tasks. The voice assistant serves as the information center, where astronauts can receive warnings, notifications, and messages. The mini-map displays the astronauts' destination, home base, and no-go zones. The user is fixed in the center and is always facing forward. When they turn, the mini-map rotates around them. If an issue occurs with the astronaut's partner, their status will turn red, which can be further expanded. Warning messages contain their cause and instructions to solve the problem. Warnings that won't immediately affect astronauts' lives are displayed in orange. Once dismissed, an orange dot is kept above the voice assistant. Astronauts are able to set waypoints at their current location through voice commands. The voice assistant provides guidance and instructions as the astronaut drops and names a waypoint. QR codes are assigned to individual sample containers. When a QR code is scanned, a GeoNote will begin. The voice assistant will display the GeoNote duration, the number of images taken, and a red dot indicating that note-taking is in progress. Once the camera is activated, the window will be wrapped in a green ring indicating the camera field of view. After taking the photo, it'll briefly stay under the voice assistant before disappearing.
For perspective, this is how our design appears in the HoloLens.
CLAWS plans to continue work on Atlas over the coming year. In addition to migrating our mockups to the HoloLens, conducting testing, and finalizing control room functionality, we are planning on building external hardware components, integrating Vega into Atlas, and developing Rigel, and which will handle hazard detection and collaborate with NASA's Survey on a Trek API. In May, our team presented its work during the University of Michigan Space Symposium Day. We have also been accepted to present at IAC 2020 and the Women in Space Conference. Thank you for listening. If you have any questions or would like to chat, please feel free to reach out to us. Go Blue!